Okay, we have seen the duplication formula. So let's look at gamma, beta, and duplication formula. Now, gamma of m plus half is equal to 1 by 2 to the power of 2m times root pi times 2m factorial by m factorial, where m is a positive integer. Okay, let's see how we can show that. Looks very similar, right? But here we have factorials and here we have gamma. So let's see. Gamma of m times gamma of m plus half is equal to 2 to the power of 1 minus 2m times root pi times root 2m. That is our duplication formula. Let's take this gamma of m to the other side. So gamma of m plus half is equal to 2 by, so 2 to the power of 1 times 2 to the power of minus 2m. So that comes down times square root of pi times gamma of 2m by gamma of m. Generally speaking, gamma of m is equal to m minus 1 factorial. So we are converting this gammas to factorials. So gamma of 2m is equal to 2m minus 1 factorial and gamma of m equal to m minus 1 factorial. Now substituting it, we get gamma of m plus half is equal to 2 by 2 to the power of 2m times root pi times 2m minus 1 factorial by m minus 1 factorial. What we want is 2m factorial and m factorial. So let's multiply both the numerator and the denominator by 2m. Let's rearrange. So this 2m, we bring it in front of 2m minus 1 factorial, and 2 we take it to this fraction so that m remains here, m times m minus 1 factorial. So immediately you know that you have reached your destination. 2m times 2m minus 1 factorial is 2m factorial. And m times m minus 1 factorial is m factorial. And here 2 and 2 cancel out and we are left with 1 by 2 to the power of 2m, which is what we had to show. Now let's look at the next one. Integral from 0 to pi by 2 of sine to the power of n theta d theta is equal to root pi by 2 times gamma of n plus 1 by 2 divided by gamma of n plus 2 by 2 for any n greater than minus 1. Now let's take this sine n theta from 0 to pi by 2. Here theta equal to 0. We know sine theta is approximately equal to theta, which implies sine to the power of n theta is approximately equal to theta to the power of n. So the integral behaves like theta to the power of n d theta near 0. And this converges only if n is greater than minus 1. It has a restriction of n being greater than minus 1. We equate integral from 0 to pi by 2 of sine n theta d theta to integral from 0 to pi by 2 of sine 2x minus 1 theta times cos 2y minus 1 theta d theta. Now how can we equate this? By making 2x minus 1 equal to n. And since cos is not there on the left hand side, we equate 2y minus 1 to 0. Solving for x and y, we get x equal to n plus 1 by 2 and y is equal to 1 by 2. We also know that integral from 0 to pi by 2 of sine to the power of 2x minus 1 theta times cos to the power of 2y minus 1 theta d theta is equal to 1 by 2 times beta of x comma y. That is the reason why we had equated this integral with sine n theta. Integral from 0 to pi by 2 of sine n theta d theta is equal to 1 by 2 times beta of x comma y, where x is n plus 1 by 2 and y is 1 by 2. Beta of n plus 1 by 2 comma 1 by 2 is equal to, converting it into gamma, gamma of n plus 1 by 2 times gamma of 1 by 2 divided by gamma of n plus 1 by 2 plus 1 by 2. But gamma of 1 by 2 is root pi. Yes. And here in the denominator we have gamma of n plus 1 by 2 plus 1 by 2, which becomes gamma of n plus 2 by 2. In the numerator, we have gamma of n plus 1 by 2. The denominator 2 comes from this 1 by 2, which is what we had to show. Let's look at the same thing in terms of cos. Integral of 0 to pi by 2 of cos n theta d theta. Again, the condition is n is greater than minus 1. Near theta is equal to 0. Cos theta is equal to 1. So no problem. But near theta is equal to pi by 2, there is a problem. Let's look at what the problem is. Theta is equal to pi by 2. So let u is equal to pi by 2 minus theta. When theta goes to pi by 2, u goes to 0. And cos pi by 2 minus u is sin u. That means the problem that we faced in the previous example applies here as well. The only thing is, in case of sin and theta, the problematic limit was the lower limit. Now here the problematic limit is the upper limit. So as previously seen, integral 0 to pi by 2 sin and theta behaves like integral theta to the power of n d theta near 0. And this converges only if n is greater than minus 1. So which means cos n pi by 2 minus u converges only if n is greater than minus 1, because they are equal. Now that we have got this clear, let's go back to our integral. Integral from 0 to pi by 2 of cos n theta d theta. Now let's convert it into a product of sine and cos. How can we do that? We can write it as integral from 0 to pi by 2 of sine to the power of 0 theta times cos to the power of n theta d theta. And that we can equate it to the identity. Integral from 0 to pi by 2 of sine to the power of 2x minus 1 theta times cos to the power of 2y minus 1 theta d theta, which is equal to 1 by 2 times beta of x comma y. So now here what is happening? 2x minus 1 is equal to 0 and 2y minus 1 is equal to n, which means x equal to 1 by 2 and y is equal to n plus 1 by 2. Now, we also know that beta of x comma y is equal to gamma of x times gamma of y by gamma of x plus y. So, we can now write integral from 0 to pi by 2 of cos n theta d theta is equal to, here gamma of 1 by 2 is equal to root pi. So, we have root pi by 2 times gamma of n plus 1 by 2 divided by gamma of n plus 2 by 2. Which is what we had to show. So that is another piece of information that we have now. So now basically what we have is the easy way of figuring out the integral of powers of sine and cos. So let's look at two concrete examples. Let's look at integral from 0 to pi by 2 of sine to the power of 6 theta d theta. Immediately we have the formula. We just apply that. We have root pi by 2 times gamma of 6 plus 1 by 2 divided by gamma of 6 plus 2 by 2, which is gamma of 7 by 2 divided by gamma of 8 by 2. So now that is equal to root pi by 2 times 5 by 2 times 3 by 2 times 1 by 2 times root pi times the reciprocal of the gamma 8 by 2, that is gamma of 4, which is 1 by 3 times 2 times 1. And simplifying that, we get 5 pi by 32. Let's look at an example for cos also. So integral from 0 to pi by 2 of cos to the power of 9 theta d theta. Again, straightforward, we apply the formula. Root pi by 2 times gamma of 9 plus 1 by 2 divided by gamma of 9 plus 2 by 2. which becomes root pi by 2 times gamma of 10 by 2 by gamma of 11 by 2, which is equal to root pi by 2 times gamma of 5 by gamma of 11 by 2, and which is root pi by 2 times gamma of 5 is 4 factorial divided by, since we are dividing, we have 9 by 2 times 7 by 2 times 5 by 2 times 3 by 2 times 1 by 2 times root pi, and simplifying it we get 128 by 315. So that was some additional exercise. Now, if you found this useful, don't forget to like, share, and subscribe. Questions, suggestions, and comments are always welcome. Thanks for watching. See you in the next session. That's it for now.